experiment A9 is the preparation and separation of an organic product. So the first thing to notice is the safety. So I've got the room ventilated well, I've got the fume cupboard here for the substitution part of this, I've got splash-proof goggles and gloves on, and I've taken jewellery and things off from my wrist just in case, like so, and I'm avoiding any naked flames in the room. So the substitution reaction, the first part is adding methyl propantol to a measuring cylinder. So I'm just going to add some of this stuff to this measuring cylinder and then measure and record the total mass. I'm just going to go into the fume cupboard. I haven't actually got the fans running at the moment. I will get those running when we do the substitution reaction itself, but for now I'm just in the fume cupboard. It doesn't actually have to be particularly accurate. I'm just being careful not to spill this everywhere. So just approximately 10 centimetres cubed. So another couple of pipette loads to go into here. Oops. And that's probably about right. So I'll just put the top back on that one, and I'll leave that and the pipette in the fume cupboard. So the first thing I'll do is just record the mass of that total, and the total mass of that one, 31.76 grams. 31.76. So the measuring cylinder plus alcohol. That's the mass of that lot is, what did I say, 31.76. It's a GDP balance, so plus and minus 0.01 grams, like so. I'm going to pop that into this piece of apparatus here. This is a separating funnel. On the separating funnel, I've just popped a stopper on the top of that. For now, I'll take that off obviously to get the substance in, and it's got a tap just like on a burette tap here. So there's a channel that runs through this. It runs parallel with these two parts of the tap here, these two handles. So at the moment that tap's closed, if I move it to there, the tap is open. So I'm closing the tap first. I'm going to take the lid off that off the separating funnel, and just very carefully pour in the alcohol like so. And I'm going to sit that back onto the measuring, onto the top hand balance, and just pop that stopper back into here. So the balance mass now of the measuring cylinder, now this time without that alcohol, is 24.19 grams. So the mass of the measuring cylinder plus any residue is 24.18 plus and minus 0.01 grams, like so. So that allows us to do the weighing by difference method and work out the accurate mass of the alcohol which has been transferred into this separating funnel. In the fume cupboard, I've got some ice cold hydrochloric acid here. It's concentrated hydrochloric acid. So this is the substance that we need to be particularly careful with. Ice cold concentrated hydrochloric acid, like so. I'm going to move the whole experiment into the fume cupboard in a moment, because I need to add to that 20 centimetres cubed of the ice cold concentrated hydrochloric acid, about 3 centimetres cubed at a time, and shake between additions. So to do that, I'll take this and I'll add the 3 centimetres cubed, then I'll pop the stopper on and give it a good shake, and then I'll do the same again, give it a good shake, same again, give it a good shake, and then I need to leave that for 20 minutes. All of that has to happen in the fume cupboard with the fans on, so you won't be able to hear me and you won't be able to see it brilliantly. So we'll come back to this once it's had its additions and it's 20 minutes. The separation method used in this experiment is simple distillation. So I'm going to show you how to set up the simple distillation apparatus. It's always a good idea to set up the glassware before you get any of the organic chemicals involved, because as soon as you get the organic chemicals involved, you're introducing more hazards, flammability, it might be toxic, and so on and so forth. So it's better off if you just try this out with clean and dry glassware first, make sure you're happy with the setup, and then you can move much more quickly when it gets to the stage of having the chemicals involved. So we're going to do this separation in a pear-shaped flask, which looks like this, and I'm going to add to that pear-shaped flask something called some anti-bumping granules. Now these anti-bumping granules are just very tiny bits of ground up glassware. And those anti-bumping granules just provide little surfaces for bubbles to form. So it allows small bubbles to form when this boiling starts to happen, which means that the boiling is nice and smooth rather than forming a big bubble which can then bump across, and that destroys the separation altogether. So just some little bits of ground glass, and it's a good trick to put those in first before you pour anything liquid around the sides here, because if any liquid sticks to the joint up here, they get stuck to it and then the joints don't go together properly. So I'm just going to clamp that vertically using a clamp and stand as normal. Notice that I've got this over the stand so that it's nice and stable, whereas something at this side is very easy to knock over and something at this side is easy to knock over. This is really stable, so it points the same way as the base of the clamp. We're going to put into that an adapter. This glassware is called Quick Fit, and it's specially designed for these examples of glassware to just fit together nice and quickly, just like a little puzzle. So put that onto there, and I could put a joint clip on there as well, just to hold it nice and securely in place. So that's now nice and secure. I'd like to be able to measure the temperature of the distillate. And so in order to measure the temperature, I'm going to use a thermometer. I've put it into this thermometer holder and adjusted that so that the bulb of the thermometer, in fact that looks just a little bit too low, so I'm just going to release the pressure, just take that clip off a little slightly, move it up ever so slightly and then twist it back to secure it, just making sure it's at that junction there so that I can measure the temperature of any distillate coming off. Now imagine that this starts to boil and releases gas, and the gas will expand and fill all of the space available. So the idea is that the gas fills all the space available, including coming down this little exit here to the adapter and into this tube here, which is called a leaded condenser. So if I then clamp that condenser carefully here, like so, and if I cool this condenser down, then that will allow the vapour to condense, and because of the angle of this, it will condense and it drips down the side here and out here. So we need something to collect in. Now the only way that that will work, the only way that that will cool down and condense is if I attach it to a cold water supply. So I've got some tubing here attached to a cold tap, and notice that I'm putting the cold water in at the bottom, and the water comes out at the top. So I'm popping those little attachments on. Notice how I'm supporting the glassware as I'm attaching really close, so supporting the glassware close to my hands as I'm attaching any tubing to that. And if I turn on the tap like so, nice and carefully, what you should see is that some cold water should, there you go, fill up the condenser, and that now is cold water circulating from the cold tap. It's not got to be running too fast, so it just needs a trickle really of cold water just to keep that cool. So now any vapours which hit this surface hit a cold surface and run downwards because of gravity. The final thing to notice then is that we need some way of collecting our distillate at the side here, and that will eventually be collected into this tube. So this tubing here, or this test tube here should I say, can just sit nice and carefully just like that, and it's ready to go. Method step 6 is recording the mass of a clean, dry, stoppered test tube, which eventually will be there to receive the product on the distillation. So I'm going to start off by just popping a beaker on the balance. There's nothing fancy in that except for it's just some way of holding this empty test tube. So pop the beaker on the balance, and I'm going to tear the balance like so. So that's now 0.00 grams. Pop the stopper on, make sure that the test tube is nice and stable, like so. And the mass then of the empty tube plus the stopper is 32.19 grams. So 32.19 plus or minus 0.01 grams. And that's just going to be kept for later. The next stage then, we've now got the reaction mixture here, so I've taken it out of the fume cupboard, it's finished doing its substitution reaction. So what we can start to do now then is separate the product from the reaction mixture. So perhaps you can see just about inside here, it's perhaps not massively clear, but there's two layers in this separating funnel. There's a clearer layer up here and something that looks a little bit cloudy down the bottom, but there's a layer in between those. And that's why we've used the separating funnel as a reaction vessel here, because it allows us to separate off those two layers. So the method says run off the lower aqueous layer into a stoppered and labelled 50 centimetre cube conical flask. So I've got a conical flask here. I'm just going to call it aqueous layer and the experiment number, which is A9, okay, so that we don't get mixed up with other things when we're dealing with the tidying away from this experiment. So I'll just lift this separating funnel up slightly on the clamp stand so that I can fit the flask underneath it, but then I think I'm just going to move it back down slightly so that we don't risk that spilling all over the place. Now, the next thing to notice about a separating funnel is that we need to be able to allow the air to come in to put pressure on this to drive the liquid downwards, which at the minute it can't do because I've got a stopper in the top of it. So I need to remove the stopper from that separating funnel. I'm just going to pop that actually in the fume cover out of the way, more because it's just out of the way than it needing to be in that fume cover. Then I'm going to very carefully open the tap like so. So I'm going to turn the tap and open it up like that. You should be able to see the level and the separating funnel dropping down nicely. So open the tap and the levels are dropping down nicely and quite rapidly. So in a moment I'm just going to slow this right down so that it's drop by drop coming down this funnel, just like that, so I don't lose too much of my organic layer, which is that top layer that I'm interested in. Drop by drop by drop, the meniscus has just gone through and I'm stopping it there. So now I've separated out an aqueous layer at the bottom and the organic layer with the product we're interested in at the top. It then says to the top layer, add 2 centimetre cube portions of sodium hydrogen carbonate solution until no more effervescence is observed. Shake and open the tap after each addition. So I'm going to take some of this sodium hydrogen carbonate, 2 centimetre cube portions. It doesn't need to be perfect, so I'm just going to use this as a guess for 2 centimetres cube like so, and perhaps you observed some effervescence in the bottom like so. It says to shake and open the tap after each addition, so of course I need the stopper that I just discarded, so I'm just going to take the stopper like that, just release that for a moment, lift that out of the way. In fact, I think what we'll do is stopper this and pop it to one side, and I'm going to give that a good shake like so. Just get a little bit of tissue for that solution that's just spilled out the bottom there. Clean that up straight away. There we go, give it a bit of a shake and just gradually gently release that stopper, okay? So I need to do this several times until there's no more effervescence observed. So take another portion, watch carefully. Is that still fizzing? There's some slight effervescence there, so give it a good shake again. And carefully release the stopper. So we'll get another one. I think that was 2 portions. Still slight effervescence, I think. Yep, very slightly, so do the same thing again. And I'm going to keep doing that until we don't see any effervescence again. Okay, so I've finished adding the portions of sodium hydrogen carbonate until the mixture stopped effervescing, lifting up the stopper between those additions, and I've just left it on this stand, just clamped out of the way for a few moments to allow the new layers to separate out. So again, we should have in the bottom an aqueous layer, which notice is quite big now because I've been adding several portions of the sodium hydrogen carbonate aqueous solution, and then the top layer which has got the product that we're interested in. So again, I need to just separate out that aqueous layer. So I'll remove the stopper from this flask again, just lift that up slightly out of the way and clamp it back down. Notice on these clamps, there's one arm which moves and one arm which is stationary, and it's really useful if you work out which one's which, because the stationary arm, get it in the right place like so, and you can just clamp and support rather than trying to move everything around in 3 dimensions. Okay. So again, I need to just remember to take the stopper off, otherwise nothing will come out of this flask. This funnel. I'll just twist that round so I can get my hands in there a bit better. And again, I'm watching really carefully, so I'm running that aqueous layer quite quickly into the bottom, but then when it gets to that narrow part, just slowing it right down. So one drop at a time, allow that to run down so I don't lose too much of my product, but I need to make sure that I don't have any of the aqueous layer left. And so that now should be the organic product in the top. I'm just going to lift this out again so I can get rid of the flask at the bottom now, which I'm not really massively interested in. Just check there's no drips on it this time. And pop the stopper into there so that can be discarded and dealt with later. Let's have a look at what happens next then. Run off the lower aqueous layer into the conical flask using step 7, then pour off this top layer into a dry, clean, labelled stoppered test tube. Now notice this is a different stoppered test tube from the one that I've measured the mass of already. So I'll just grab a second one, which I think I have in a tray over here. And I'm going to just pour that into here, labelling that as the organic product from A9, like so. So I'm going to just pour this organic layer very carefully into the dry labelled stoppered test tube. So just carefully pouring across like this. And it's probably worth putting the stopper back onto that separating funnel. Just clamping that up safely. If you're working in pairs or whatever, you might be able to work together and somebody could then be dealing with the disposal and the tidying away of that. But I'm working on my own, so it's just useful to have that clamp there nice and safely. This one here. It now says add a small spatula measure of anhydrous without water, magnesium sulfate powder to this stoppered test tube. So I'm going to take the stopper off here and add, now it says a small spatula as opposed to a micro spatula, so I think I'll take a normal size spatula, but I certainly don't need it to be heaped, so something like small spatula, something like that perhaps. Pop that into there, pop the lid back on the magnesium sulfate and put the stopper back on, and it says, I'll give it just a little shake, okay? Then I'm just going to let that just separate out a little bit. And the final step for this substance is to decant, so carefully pour that liquid into the pear-shaped flask for the distillation and then separate by distillation. So I'm going to take this, carefully pour it into that pear-shaped flask from the earlier distillation apparatus and then have a go at the distillation. Okay, I've decanted off the organic product into the pear-shaped flask here and reassembled this apparatus for distillation. This is the stoppered test tube, obviously without the stopper at the moment, that I recorded the mass of earlier. And so what we're going to do this time is distill off the product into here. The product then is the fraction which has a boiling point range of 47 to 53 degrees C. So I need to keep an eye on the thermometer here, and as soon as it gets to that 53 degrees C, if it starts to get higher than that, I'm going to stop. Similarly, if this starts to run out, I'm going to stop because you mustn't heat to dryness in organic chemistry. So we'll keep an eye on that and see how it goes. And then what I can do is restopper that flask, reweigh, and it gives us an opportunity then to measure the mass of the product that we've got produced. So I'm going to use this little tiny Bunsen burner here. It's called a micro burner. Notice that I've set all of this up before bringing in any naked flames, just to minimise the risk from the organic substances and the flames. Also notice I've got plenty of heat-proof mats around and about, and I've got a spare one, so if something happens and I need something to extinguish the flame before going and getting the fire blanket or whatever, I've got something easily to hand to do that. But by heating this carefully and with a micro burner, we should be fairly safe. So, just checking before I do that the water is still running through that condenser, which it is. Everything looks as if it's set up nice and safely. It's all in line, it's all attached properly. So let's go. So I'm going to just turn this onto a blue flame. I'm just going to heat gently by going on and off like this, on and off. And you can perhaps already see some little bubbles. That's probably dissolved gases rather than anything, just coming up from those anti-bumping granules at the bottom of this pear-shaped flask. Remember those being there to allow that to happen smoothly rather than all happening in a big rush, to avoid pressure build-up, to avoid it from bumping. So that allows that smooth boiling, and I'm just going to heat this nice and gently on and off until we get to between 47 and 53 degrees on this thermometer. Okay, so the temperature inside this piece of apparatus here is now up towards the mid 40 degrees. And I can certainly see drips coming down from that thermometer, so these vapours rising, cooling, condensing, dripping down. But of course, as they cool and condense, there's a slight release of heat there, so some heat release to the surroundings, so it gets gradually warmer and warmer. And up on this thermometer, the scale is looking at around 47 degrees, so I'm expecting the fraction to start to come off. And lo and behold, right on cue, just down in this test tube down here, hopefully you can see that we've got some condensation and the liquid product coming off here. Now, because this organic product, this particular one, is not massively volatile, and because its boiling point is well above room temperature, actually condensing in just a test tube like this works quite well. For some organic substances, it might be important to cool the receiver, because some of them are so volatile that they would drip down into here nice and cool, but at room temperature would then start to re-evaporate as well. So I'm just going to keep heating and allowing that to carry on. The temperature dropped slightly there. I think I stopped heating because I was too busy talking. And the temperature's back up at about 47 now. It's not really exceeded 47, 48 at the moment, which is because this is coming across now. We've reached a boiling point of this sample here. You might notice that the volume of liquid is dropping quite considerably in here. I don't want that to get to the stage where it's heated to dryness, and I certainly don't want to get to the stage where we're getting any contaminants coming across. So I think we've probably got the idea now. I don't really want to go any lower in this pear-shaped flask than about there, so I'm going to stop heating that now, even though there's still some sample and some sample which could be boiled. It's just not safe to heat to dryness, because that ends up as a fire risk down at the bottom here. So I'm just going to let that now cool down, allow the distillate to come across. I'll turn that Bunsen burner off at the earliest opportunity now, because we've got flammables still in the lab, and that's best practice in terms of safety. Just allow the rest of this to condense and to drip down. There's still 1 or 2 drips down, and when that's finished, I'll stop at that test tube and we can record the final mass. So here's the stoppered test tube with the organic product which we've distilled across. The beaker is on the balance. I'll tear the balance again, so that's 0.00 grams, which just then allows me to pop that into there like so. And the final mass then of the tube, the stopper and the product that we've made is 34.24 plus or minus 0.01 grams. So that information could then be used to, for instance, calculate the percentage yield of this synthesis that we've done.